Good morning, Abyssers. We are entering our final week of live presentations. The first one this week is about to begin. We got a huge crowd today, so you may have some verbal interruptions. There may be cheering and clapping and thunderous applause. If you're not able to hear it, it's simply because my audio is not working well. So, without further ado, go ahead and start.
Okay, so my movie was Proof, and this is my mathematical analysis of it. This is a spoiler-free summary up here. I have a more in-depth summary, like on the next slide. So Catherine Lewin spent her last 5 years caring for her father, Robert Lewin, who developed some sort of mental condition. They didn't name it or anything, but he did die of like a brain. Okay, I'll get back to that. Hal, who was a recently graduated student of his, was going through all of his notebooks to make sure he didn't have any last, final proofs written down during his episodes. And Claire, Catherine's sister, flew in to come for the funeral, and she's been trying to get Catherine to come home just in case that Catherine might have inherited his disease. This is the more in-depth summary. These are more like points I prepared so I could explain it better. In the opening, she's talking with her father, and it's her 21st birthday. 27th birthday. And he gives her a bottle of champagne. And they talk a bit, and she tells him about how she's worried about how she's going crazy like him, and he says that if you were wondering about going crazy, then you're probably not crazy. And then she reverses it back on him because he's wondering about that too, but he did. But then she realizes that's a delusion because he's dead, and he tells her that. And then Hal comes in, and he's talking about about how great it would be if he discovered any theories in there, and she tells him that he can't take any of the notebooks. But she gets paranoid and she dumps out his backpack. She doesn't find anything, and she feels bad about it. But then as he's leaving, he forgets his coat, and she picks up his coat, and a notebook falls out. But he says that he was going to give that back to her as a birthday present because he found a lot of stuff about her in it that her father wrote before he died. But she's still really upset with him because he lied about taking a notebook, and she calls the police before he gets her to read the notebook, and then she kind of forgets about the police and lets him go. And then the police come by, and she has to explain that to them. So then her sister comes in. Her sister comes in for the funeral, and she Claire tries to get Catherine cleaned up because she's been kind of depressed, understandably. And then when they go out, she talks about how she's worried about Catherine because she heard the police came by, and Catherine had been kind of abusive, they said, towards the police. Yeah, because I think she shoved one of them and said a lot of obscenities. So they fight a bit, and then they go to the service where Catherine interrupts someone else, or interrupts the service as someone is leaving from the podium, and she explains a lot about. She accuses everybody of being. She says she didn't know. She said she didn't know that he had so many friends, and she wondered where they were for 5 years while she was caring for him alone. And then she says some embarrassing things about her father, how she had to bathe him, and how she used to get him a lot of books from the library, but it turns out that he was just grabbing all those books because he thought aliens were sending him a message through the Dewey Decimal System. The library information system. And so she ends by saying she's glad he's dead because she doesn't have to care for him anymore, kind of. And then she goes out and immediately regrets it when Hal comes out. And then she walks home. The after party happens then, or later that night. And Hal is there, and he talks to her a bit, and she kind of warms up to him. And there's a scene where Catherine and Hal kind of banter a bit, where Catherine says her dress doesn't fit her, and Hal's yeah, it does. And she's you can't prove it. And he says, I can disprove the opposite. And I'll explain why I found that significant later. So later, the next morning, Catherine's doing a lot better, but then Claire tells her that she's selling the house, even though she lives there, because that's where her father lived, and the University of Chicago, which is where they are, wanted that house back. So after they fight a bit, Catherine ends up giving Hal the key to the desk with an important notebook that she was hiding. So Hal goes and finds it, and he brings it back, and he's like really excited. And he tries to put the credit onto Catherine, who says she doesn't want it, and after a bit more arguing, Catherine ends up saying that she's the one who wrote it, not her father. But no one ends up believing her because she doesn't... The movie hasn't really put a lot of emphasis on her being a mathematician herself, which I guess fits in here, but it kind of bugged me. So Claire thinks she's just delusioned and thinking that it's hers, even though it was her dad's, and Hal thinks that she doesn't have like the mathematical capabilities to do it. So no one believes her. After Hal takes it to go get it verified, she kind of goes into like this depression where she doesn't speak for like the next week. But in this, it shows like different clips of like the last 3 years with her father when she was developing the proof with him, and clips of it being verified. A scene I kind of found, kind of funny in there was, this isn't actually relevant to the rest, so it was just like, she was depressed then too, because he had recently been doing better and now he wasn't again. And so she's kind of wasted 33, he accuses her of wasting days, and he makes her say like how many days, because he bet she counted and it was 33 days. And then he wanted her to be more precise, and she said till like noon. So that was 33 and a quarter days. So then he said, wouldn't that be interesting if that was in years? And she said, why would that be interesting? It's depressing. And he says, no, because how many weeks is that? And she says, 1,729. And then he says and then he makes her say why that's interesting, which is because it's the lowest number that can be expressed as the sum of two cubes in two ways. I thought that was weird that they just brought that up, and they called it mathematical depression, so I don't know. After getting it verified a week later, just as she's about to leave with her sister back to New York, he runs in and tells her that he's sure that it's hers, because there's a lot of like newer mathematical techniques that her father wouldn't have used, like random matrices, which I won't really get into it, but I'll explain why that's kind of why I found that significant later too. Catherine doesn't take the notebook back from her because she's still upset with him, and so like as she's driving away, he throws the notebook in through the window, and she picks it up. But like last minute, just as they're getting on the airport, she runs out of the airport, and she goes to him, and they kind of talk about it in the closing scene, the proof. Okay, here's my review. I gave it 4 stars. I really did enjoy the film. It was like really easy to feel the emotions of all the characters, which was mostly just like stress and stuff. But my only nitpicks were that like there wasn't actually that much math in the movie. I mean, I didn't count that against the movie because like it wasn't written specifically to have math in it. But one thing I didn't like was that it didn't really focus on Catherine herself as a mathematician. Like it just kind of dropped that in like halfway to 3/4 through the movie. So 4 to 5 stars, I guess. And then here are like the mathematics. I really wanted to know what that proof was, and like the problem with like movies about new mathematical proofs is that unless it's about like someone specific, they can't use a specific proof. Otherwise, they'd be like taking the credit away from them and putting it on like a fictional character. So they had to like have some obscure proof that either some obscure proof that hasn't been proven yet. But I mean, this wasn't exactly obscure, I think, from the evidence given. Given that Hal was like super excited, he said it was about prime numbers, it like narrowed it down some. But then there was a scene when she was working on the proof with her father about Landau Siegel zeros, a modification of it, she said, that got her a lower bound for L. And then her father said something about Siegel zeros. And that's significant because that's a potential counterexample of the general Riemann hypothesis, which I'll explain a bit more later. So I'm going to start with the zeta function, then I'm going to go into the Riemann hypothesis, then I'm going to go into the general Riemann hypothesis. The Riemann zeta function was actually first introduced by Euler. It's sometimes known as the Euler-Riemann zeta function. It was introduced by Euler in the mid-18th century, but it would only was considered for the real plane because there wasn't really complex analysis back then. But then, like, give or take 100 years later, Riemann extended it to the complex plane, and he provided a proof that connected its zeros to the distribution of prime numbers. So that's the Riemann zeta function. I thought it was, I mean, it looks a lot like the P-series, and it kind of is, but the P-series is like only real numbers, like integers and stuff, but the Riemann zeta function applies to like complex numbers. It's a complex variable. And just like the P-series doesn't converge for anything below 1, this function isn't defined for when the real half is below 1. I'll explain that after the next slide. I'll come back to that one. So complex analysis is like a subject of mathematics that lets us continue, it was used to continue the function beyond that. When you, they redefined the function for below 1, and while you could, technically define it any way you wanted to, there's only one way to define it where it still has a derivative over all points, where it's still analytic. And so they define that using the Riemann functional equation, which is that. Where this is the gamma function, which describes factorials, but they extended that to be that, so that it's more defined than just integers. They're not like the same thing, like that. This wouldn't describe what that is, because if you put -1 into this, you'd end up with -1/12, which wouldn't make sense if you put -1 into that. And also, if you put any negative even integer, you'd end up getting 0, which again doesn't make sense for the Riemann zeta function. Okay, so the Riemann hypothesis, originally, along with Goldbach's conjecture, I think that's his name, were combined into one of David Hilbert's 23 unsolved problems. But then the Riemann hypothesis also ended up on its own as one of the 7 millennium problems, which the Clay Mathematics Institute is offering $1 million for a solution to, which I thought was interesting. So the Riemann hypothesis itself, okay, well first, there's a critical strip between 0 and 1 on the Riemann functional equation that we know all of the zeros exist, all of the non-trivial zeros, which are all the negative integers, they all exist in this strip. The Riemann hypothesis states that all of them are on this line, which is where the real half is equal to, the real part of the variable is equal to -1/2. The Riemann hypothesis itself is significant because you can use it. There's another function that mathematicians use to describe the distribution of primes, but it relies on this, and proving this would make that a lot more accurate, and it would say something about how exactly chaotic prime numbers really are in their distribution. The generalized Riemann hypothesis states the same thing for the Riemann zeta function, but for all Dirichlet functions where the Dirichlet character, I think it's chi, is the pronunciation of that x character, where chi is a completely multiplicative arithmetic function where where chi of n plus k, where there's some k that equals the same as x, some positive integer k that's the same as chi of n. And for all n of chi of n equals 0 when the greatest common denominator of n and k is greater than 1, and where s is some complex variable. So the way that Siegel zeros are relevant to this are that they describe potential zeros of the Dirichlet. This one is more of a disproof of the generalized Riemann hypothesis than the Riemann hypothesis, because this states for Dirichlet L functions where the real half of s is very near to 1, means there are still zeros there, which would mean it's not all where 1/2 is the real half, or the real part of it. Catherine at some point mentions being able to find a lower bound for L, and I figured this could also be reference that, since that's the function variable, not the function variable, it denotes the function. And the original proof that suggested this, there wasn't a lower bound, C of epsilon q to the negative epsilon didn't have a lower bound. So when she said she found a lower bound, I figured that probably had something to do with this. So the reason I mentioned random matrices was because that was referenced. There's a conjecture about that, the Hilbert-Hoyle conjecture. I feel bad for messing up all these names. Where they made a conjecture where that random matrix would be significant in proving the Riemann hypothesis. The reason I found this part significant was because when I described she found when she was working with the Landru-Seagulls, that would disprove the general Riemann hypothesis, which most mathematicians believe to be true. But she could be disproving that, like disproving the opposite of the general Riemann hypothesis, which I figured. I thought that would be like a nice little Easter egg if they put that in there, which they could. So, yeah. I think that's it then.
Wow. I should have had an applause.